Let's say this is one first problem. It says that consider a system supporting logical address is 32-bit, physical address is 27 bits, uh, page size is 4K, page table entry it is 3 byte. What is the page table size? So it is asking for the page table size here, and many things has been given. Now, what we have to calculate at last, we have to calculate the page table size. It is not asking about the frames, right? It is just asking about the page. So let's try to solve it. Now here what will happen is, first what is given, we'll write it out. So the given is logical address, which is of 32-bit. We have the physical address, which is of 27 bits, right? We have the page size, which is of 4 kilobyte, and it is written page table entry, which is E, which is equal to 3 byte. So, which is, and we know that the one word equal to 1 byte. So, what is logical address space? So, what is logical address? It is of 2 to the power of 32 words, or you can say bytes. What is physical address space? It is again to the power of 27 what words, or you can say bytes. Both are correct. Now we doesn't have to bother about this. Let's talk about the page table size. So the page table size will be calculated as, so as what I told you, if we have the page table like this, so what is the size of this page table? How many pages are there? Which is n. And what is the entry, each entry size, which is E, right? And what I have written here is page table size equal to n into E. And n, how we calculate? The logical address space divided by page size. So that formula will apply here. So page table size will be equal to the number of page table or number of pages into each entry. So what is number of pages? Number of pages n will be calculated as logical address space divided by page size into E, right? So what is logical address space? To the power of 32. What is the physical page size? It is of 4K. So it will be 4 to the power of 2 into 2 to the power of 10, right? And into E. What is E? E is 3 byte. So it is to the power of 2, and this is the to the power of 12, and 32 it will be to the power of 20. Into 3 byte. So 2 to the power of 20 is nothing but the mega, right? Is megabyte. So 3 megabyte will be your answer for page table size. So this is how we'll calculate the page table size. So as you know, we have in the page table, we have entries in the page table. This will be total number of entries are n, and each entry is of E size. How n will be calculated? N will be calculated as logical address space divided by page size, and then in the entry size it is given 3 byte, right? This is how we'll calculate the page table size. Now let's go to the problem number 2. Problem number 2 is saying that consider a system with 2k pages. So we have the number of pages written, right? So the number of pages are 2k. 512 frames. So frames is also given. Let's say M is 512. Page offset is given is 9-bit. Page offset, if you doesn't remember, this is the page offset. This is the page offset. It is given. How much it is given? 9-bit. Then what is logical address space? What is physical address space? What is P? What is F? What is page table size? If E, which is each entry will have 4 byte. Like here it is written Each entry is 3 byte. Here it is written each entry is 4 byte. Okay. So now let's calculate one by one. So we know that this is the number of pages, right? So how we can find out this is written the page, right? So to page, you know that there are two things: logical address and physical address. Both are divided into two parts. Is the page and offset. Here it is frames and offset. Now the number of pages are there. How will calculate the P and how will calculate the F? So for P, it will be log of n, log 2 of n. So it will be, what is log 2 of n? So log 2 of, what is n? N is 2k. 2k means 2 to the power of 10. So it will be, sorry, 2k, 2 to the power of 11. 1k will be 2 to the power of 10 because it is 2k. It will be 2 to the power of 11. So it will be 11. P equal to 11. So here it will require 11 bits. D is already given, which is 9. Right? Now, how will calculate F? This F, frame number. So how many bits are required for the frame number? The same logic. It will be M. Now it will be log 2 of 512. How we can calculate the 512? 512, it will be 2 to the power of 9, right? Which is 9 bit. So it will be 9 bit and the offset, because it is the same for both, so it will be 9. So now it is total 20 bit and this total 18 bit. So we know that logical address is of 20 bit. Logical address is of 20 bit and physical address is of 18 bit. We have calculated P, we have calculated F. Now calculate logical address space and physical address space. So what is logical address space? It will be 2 to the power of logical address. So it will be 2 to the power of 20. It will be, what is 2 to the power of 20? It is 1 mega. 1 mega words. Right? 2 to the power of 20 words. Now, what is physical address space? It will be 2 to the power of physical address. It will be 2 to the power of 18. What is 2 to the power of 18? It is 2 to the power of 8 and into 2 to the power of 10. It will be how much words? So it is word only. It will be 2 to the power of 8 will be 120, 128, 127, 512. Kilo words, right? Now, what is a page table size? What is a page table size? How will calculate the page table size? So the page table size will be calculated as the page table size will be calculated as number of pages into entries. So what is n? N is 2k. An entry we have 4 byte. It will be how much? It is 8, right? So it will be 8 KB. This is the page table size. So we have calculated all. We have calculated logical address space, physical address space, PF, page table size. Also we have calculated. This is the page table size. So this is the answer. This is one answer. P and F. This is next answer. Then we have this one, and this one is the another answer. So we have calculated all the thing which is required here. So this is how we'll solve the problem related to the paging. And for that, the basic concepts should be clear. What is logical address space? What is logical address? How much bits is required for the logical address? And how much bits is required for the physical address? what is the entry size, what is the number of frames, what is the frame size and the page size, what is the page table entries, and all those things is require is your logic should be clear to find it out, all those things.